In this video, we are going to be talking about evaluating 3x3 systems and word problems. But let's start us off with checking a solution. So this time around, notice that this coordinate has 3 values. So we have a x value, a y value, and you can probably guess it, it's a z value. And so here, this is what we call a 3x3 because there are 3 equations and there are 3 variables. So x, y, and z. And just like before, we're going to check to see if this is a possible solution by making sure it works for all 3 equations. So that's how we can evaluate or check if a solution is true or not. So I'm going to just start us off with taking the first equation, plugging in my x, which is 3, and my 1, which is y, and my 5, that is z. So this would be 2 times 3 minus 1 minus 3 times 5. And I need to make sure that it equals negative 10. So if I work this out, this gives me, well, 6 minus 1. When you subtract, just go from left to right. 6 minus 1 is 5 minus 15. And I'm just bringing the negative 10 down on the right side. So 5 minus 15 is negative 10. So this here does work out. So I'll just leave that as a check. Let's try out the second equation by plugging in our x, y, and z. So our x here is 3 minus y plus z. So that's going to be minus 1 plus z, which is 5. Needs to equal positive 10. So 2 times 3 is 6 minus 1 plus 5. So if I take all these numbers and add them up, 6 minus 1 is 5. 5 plus 5 does equal 10. So both sides do equal 10, so this is true. So far looking good. So let's try the last one here. If I take my third equation, x, which is 3, so plug in 3 plus 2 times y minus 4 times z and negative 12. So I went ahead and plugged in my 3, my 1, and my 5 and written it out here. So if I work this out, I have 3 plus 2 minus 20. So if I add that, that gives me 5 minus 20. Well, 5 minus 20 gives me negative 15. And last time I checked, that does not equal negative 12. So this one failed. So in this case, since one of them failed, that means the entire thing here is not a solution. So this is not a solution because not every single equation works. So we're going to say not a solution. And that's it. So that's kind of the theme of our lesson today, is to evaluate 3x3 systems given an order pair. So let's talk about how do we specifically evaluate for a 3x3 system. Typically, you're given an order pair, so an x, y, z coordinate, and what you have to do with it is plug in your x, y, and z values into the equation to check if it's a solution to the 3x3 system. And the variable values need to work out for all 3 equations in order to be a solution. So let's do 2 more examples for this idea here, just to get a better sense of it. So again, you're given an order pair, so a coordinate. So this is my x, this is my y, this is my z. And it always goes in that alphabetical order. And I have my equations. And I'll go ahead and number them so I know which equation I'm working on. And so I'm going to plug in my x, my y, and my z to every equation until they work for all of the equations or until one of them fails. So here I go. So for the first one, I have 4x, which is negative 1, plus 2y, which is 5, plus 3z, which is 2. And let's see if this does equal 12. So if I multiply this out, I get negative 4 plus 10 plus 6 If I add this up here, I get, let's see, negative 4 plus 10 is 6 plus 6, and 6 plus 6 does give you 12. So I can already see that this works out. So I'm just going to stop there because I know that this is true. If I check the second equation, 2 times x, which is negative 1 plus, not plus, minus 3y, which is 5, plus 5z, which is 2, negative 7. So if I work this out and multiply, this becomes negative 2 minus 15 plus 10 equals negative 7. Well, negative 2 minus 15 is negative 17 plus 10. Yeah, this would be true. Negative 17 plus 10 is negative 7. So this is definitely true as well. Let's see if our last one works out. So we have 6 times x, which is negative 1, minus y, which is 5, plus 4 times z, which is 2, equals negative 3. So if I work this out, that's going to give me negative 6 minus 5 plus 8. And negative 6 minus 5 is negative 11 plus 8. Well, negative 11 plus 8 gives me negative 3, and that's what I have on that side there. So this here is correct as well. Since all three equations worked out with the given coordinate, that means this is a solution. So I'll say yes, it is a solution. All right, let's try another one here. So for B, I have 16 for my x, y is 5, and negative 8 is z. So again, these are my three equations. Let's start with the first equation here. So we have x, which is 16, plus our y, which is 5, minus 2, and our z here is negative 8 equals 5. So taking this equation, plugging in our x and y's, let's work this out. So this is 16 plus 5 plus 16. Okay. Negative 2 times negative 8 does give me positive 16. So I don't think I've seen anything done wrong. And I can already tell this is not going to be a solution because 16 plus 5 is 21 plus another 16. I think this is 37. And last time I checked, 37 is nowhere near close to equaling 5. So this is not a solution. So yay me, I don't have to keep going. I can stop right here. Because in this case, I already knew one of the equations failed, so let's just end that problem and say it's not a solution. All right, so there are some more practice problems of these down below in the practice problems, but I do want to go over example 2 with you guys. So for this problem here, when you're solving for a 3x3 system, essentially you are given 3 equations, but they don't give you the coordinate. Instead, you are asked to find the coordinate that works out for the 3 equations. So you have to find the x, the y, and the z that works out. And for 2x2s, we've done this before where we have to find x, y using either substitution or elimination or graphing. But for 3x3 is a little bit tricky. The only way to do it is to either kind of plug in your variables or use elimination. So in this Algebra 2 class, we're only going to learn about a specific case where they give you the z value or they give you one of the variable values and you have to work backwards to try to get all the other variables. So as you can see here, notice that they gave us one of the variables, which is z. That means I already know what the z's value is. It's negative 3. But they gave me a second equation where I have just y and z. So lucky for me, I can figure out what that y is, my missing y, if I just plug in what my z is. So if I number all these equations, I can take the second equation, 3y plus z equals 18, and plug in my z, which is negative 3. And I can go ahead and add the 3 to both sides to try to cancel out that 3. So this would be 3y equals 21. Divide by 3 to get rid of that 3 on the y. And so my y here is 7. 21 divided by 3 is 7. And so 7 here is my y value. Next, I can take now my y and z value and plug it into the first equation and then find the x value. So if I were to do that here, I'd be taking the first equation. So my x, I don't know what it is. My y is 7. My z here is -3. And so working this out, I have x plus 7 minus 15. If I multiply 5 and -3, I get minus 15. And so if I take these values and add them, I get negative 8. 7 minus 15 is -8. And so if I add 8 over x is equal to +3, -5 plus 8 is +3. And that there is my solution. So I have my x now, it's +3, and now I've completed all the variables. So in this case, my solution is 3, 7, and -3 as my order pair. That works for these three equations. And that's it. And that's it for this video. If you want to try out some more of these evaluating 3x3 problems, check out the practice problems below. There are 2 problems for you guys to try out, and feel free to use the key to check your answer. Bye, guys.